Alright, problem 4-12. Examine the figures at right and then visualize the figure for n equals 4. So we've got our second figure in whatever pattern we have here with these shapes, and we've got our third figure. So what they want us to do here is they want us to visualize what the fourth figure would look like, and then they want us to come up with how many cubes are in the figure for n equals 4. So starting out with that part of it here, let's go down here. Kind of got myself a little bit of a start here, so I didn't have to redraw everything in for you. Our second figure we know has the shape of a cube, and if we look at it closely here, it looks like it's missing one piece. Same thing with our third figure in the sequence here. Okay, it looks like a cube here, and it looks like it's missing a piece. So let's just go ahead and record the information that we know. I'm going to just go ahead and leave a little space above here, but I know that my second figure, and I'm dealing with my third figure. So how many cubes do we have in our second figure? Well, if we know that this side here is 2, we know that this side here is 2, and we know here this side is 2. So we've got length and width are each equal to 2, and the height is 2. If we were to take it and think about it like it was complete, like this piece wasn't missing, we could come up with the volume of the number of cubes. We'd have 2 by 2 by 2, which would give us 8 cubic units, but we're missing one. So if we think about that here, we've got 2 times 2 times 2. That gives us the volume of the entire cube. Okay, but then we're missing one piece, so that's like saying minus 1. So 2 times 2 times 2 is 8, minus 1 gives us 7. So we have 7 cubes there. So remember, T of n here is our number of cubes. That's important to remember there. Okay, that's what our T of n is representing. Our second figure has 7 cubes in it. Our third one here, and I'll do that one in blue so it kind of doesn't run together. Our length here, we've got 3 by 3 by 3. So if this was complete, it wasn't missing that piece, then we know that we would have 3 by 3 is 9, by 3 would be 27. So if we were doing the math there, it'd be like saying 3 times 3 times 3, which gives us our volume of the full cube if it was all there, but then we still have to take away 1. So that would be saying 27 minus 1 gives us 26. Let's go ahead and put that 26 over here. Now if we're visualizing what the next figure would look like, the fourth figure in the sequence here, we're going to have probably then, instead of being 2 by 2 by 2, 3 by 3 by 3, the fourth one would be 4 by 4 by 4. And I've already got that one kind of drawn out here for us. So if we take a peek here, this is going to be 4 units by 4 units by 4 units, but then we're still missing this piece right in here. Okay, this piece is still missing. So we've got 4 by 4 by 4 minus 1. So 4 by 4 by 4 is going to be 64, minus 1 would be 63 units, or cubic units. So we know that our fourth figure has 63 units. So let's go up here. So we've kind of visualized it here. It says how many cubes are in the figure for n equals 4. Well, we can say T of 4 is going to equal 63. So or you could say, 63 cubic units. It says how many cubes are in the figure for n equals 1. So let's think about that. If we were going to take that and draw that out here, well, we know that it would start out with dimensions of being 1 by 1 by 1, which really gives us the single cube by itself, but then remember we have to take away 1. So if you do 1 times 1 times 1, right, that gives us the volume of this, which is 1 cubic unit, but then we subtract 1 cubic unit, we would actually get 0. So this doesn't even exist. Okay, so our first term in the sequence there would be 0. So how many cubes are in the figure for n equals 1? There would be, you could say, t of 1 equals 0, or 0 cubic units, or 0 cubes. I'll write that in this case here. So I'm going to go over here and fill that in on my little table here. I have 1. This would be 0. So part C says, find the general equation for the number of cubes for any n. Verify your formula with the cases of n equals 1 and n equals 5. Well, let's think about that here. If we just took out our numerical values and plugged in n's here, we would be saying, for any one of these, we would be doing n times n times n. Right, that would give us the volume of the cube if it was complete, and then we'd be subtracting 1. Now I've written this like this each time here, but how can we really write this shorter? N times n times n is going to be like saying n to the third power minus 1. So if we take that information here, it says verify the formula with the cases of n equals 1 and n equals 5. Well, we already know that if we plug in 1 into here, 1 cubed minus 1 is going to give us 0, so we know that's right. And let's look at what the fifth figure would look like. We know that we would have a shape here that would be, and I'm not going to draw on the entire thing, so we've got just kind of a cube. Don't judge, it's hard to draw on this thing. And it's missing a piece. Okay, I have more pride than that. I can't go with that. I'm sorry. Anyway, let's jump back to it here. So we've got just a quick sketch. We've got boom, 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 and it goes up, down, and we've got, it goes almost all the way over here, but remember we're missing that one piece there. So it would come down. We've got this goes all the way to the corner. Anyway, you kind of get the idea here. We're going to have this cube here that's going to be missing the piece right there. So just remember that piece is missing. So we're going to have 5 by 5 by 5, which we know a cube that is 5 by 5 by 5 would give us 5 cubed, which would be 125. And if we take that 125 then and we subtract 1, we should end up with 124 cubic units there. So we know that our fifth one would be 124 cubes in the figure. So, is this sequence arithmetic, geometric, or neither? Explain your reasoning. Okay, now this is kind of, it's more of an important part of it here, because a lot of people are like, well, I got to figure out what the 0th term is and all that. You don't really have to. In order to see if it's arithmetic or geometric, we know that these are consecutive terms in the sequence. If it was arithmetic, give myself a little room here. Remember, if it's arithmetic, it's going to have a common difference. And if we look at that now, as we go from one term to the next here, okay, so our first term here, If we take 7 minus 0, we get 7. If we take 26 minus 7, you get 19. So already we know that it's not a common difference, so it cannot be arithmetic. So, not arithmetic. Let's think about geometric. Remember, with geometric, you're going to have a common ratio. If you take one term and divide it by the term before it, we should get the same quotient each time. That ratio should simplify to be the same. So let's try that here. Let's do 26 divided by 7. Now if we just compare that to 7 divided by 0, obviously you can never have 0 in the denominator here, so that is not going to work. So this is not going to be a geometric sequence, in which case then it's going to end up being neither. It's going to end up being neither. Now it says explain your reasoning. I'll think about it here. We could say the sequence will be neither geometric or arithmetic because there is no common difference and there is no common ratio. Ratio between the terms. So if you're looking for a reason there, that is for your last part, part D. Is the sequence arithmetic, geometric, or neither? Explain the reasoning. The sequence will be neither because there is no common difference and no common ratio between the terms, meaning can't subtract and get the same value each time. We can't divide and get the same value each time. Hope this helps. This is for problem 4-12 in your homework there. If you have questions, make sure you do ask your teacher.